Welcome to the Tech Study channel. So, in the previous class, we have discussed about some important questions. Means the last important question of a Tribuli subject, which is 12th one. And now, in this class, uh, I will explain first important question and its answer of DBMS subject, database management system. Okay, so uh, in the next videos, in the upcoming next videos, we will see all these question and their answers also. Okay, so first, evolution of DBMS. Okay, first question is evolution of DBMS. So first, we will see what is DBMS and then examples of DBMS and diagram illustrating DBMS use and evolution of DBMS in different stages with example. Okay, so what is DBMS? So DBMS is a group of programs that manipulate or store, manage and facilitate access the database. Okay, is a group of programs that manipulate means exchange. Okay, store, in brackets, store, manage and facilitate access of the database. The database means, here the database means is an organized collection of related data that can easily accessed and administered and managed by using computer based DBMS. So is an organized collection of related data. Okay, that can be easily accessed and administered and managed by using computer based DBMS. So we will see what is data. Okay, so data is a collection of raw unorganized facts and figures that can be processed to produce meaningful information. Okay, so raw or unorganized data means standalone, unlinked, uncontextual uncontextual data. Examples: number, text. Okay, means standalone means which can stand by its own, means which has a meaning. Okay, and unlinked and uncontextual data. So here contextualizing means according to any topic, organizing the text data. Okay, so so the uncontextual means data means so without taking any specific topic, the data is there. Okay, so that's why we are calling it as a uncontextual data. And examples are numbers, text, etc. Okay, numbers like 90, 85, 95, 12 means undistributed list. Okay, and text like apply, red, Hyderabad, any text. Okay, and then What is mean by processed data? Means processed data mean linking, contextualizing, analyzing data so data makes sense and has meaning. It becomes information. Okay. Then example is processing a student's unorganized monthly test scores results in calculated averages, percentage, ranking, and pass or fail grades. So this is ranking, pass or fail, or percentage and averages are processed data. And the test scores, monthly test scores are unprocessed data. Okay, means raw data. Okay, then another example is here scanning a product barcode processes unorganized item numbers and prices into an itemized customer receipt with tags and grand total. Okay, so uh, we are calculating the number of items and prices, then we will get the tag and grand total. Okay, so this is the processed data example, tag and grand total, and the number of items and prices are raw data. Okay, so it becomes the meaningful information after processing. And then what is related data? Related data means how pieces of data connect to one other logically within the system. Okay, so examples are customer name, their product, their purchase history, and shipping address, etc. Okay, these are the pieces of data. Okay, customer name is a one piece of data, and purchase history one piece of data, and shipping address is one type of data. So how they are related logically, so that is called related data. And then so processed data helps to find a relation between different types of data. Okay, this is the relation between a processed data and a related data. Means a processed data helps to find the relation between different types of data. And SQL, so next we will see the examples. Example of DBMS, database management systems are Oracle database, MySQL, MongoDB, SQL server, etc., and many more there. Okay, here is the diagram. Okay, here is the database management system, SQL, and application software end user, DB designer or programmer, DB administrator or DB administrators, and DB administrator software. Okay, so here is the explanation of this diagram. So SQL is a language used to communicate through the interface. So DBMS is a group of program that manipulate, store, manage, and facilitate access the database and provide interface between database and user of the database. So here SQL is a language used to communicate through the interface. So this provides the communication between user and database, okay, through an interface. And then here we have, so here this diagram in, illustrate data through the multiple layers of software. So these are the multiple layers. These are the multiple layers of software. Okay. So data through the multiple layers of software. Okay, and then so and what is database we already know. So and DBMS also we already know, and SQL also we already know. Language, it's a language used to communicate through the interface between user and database. And then so what is application software means? Application software, these are the programs that end user interact with to perform specific task. These are the programs, okay, that end user, this user interacts with to perform specific task. And instead of talking directly to the database, users use this software which sends requests to the DBMS on their behalf. So it sends the request to the DBMS, okay, which is provided by user. Okay, then example is banking app on phone, Amazon website. So banking in a banking app, this app sends the request to the DBMS. So uh, if we want to access the data, if we want to access the balance, and if we want to credit or debit anything, so to change the balance of the account, so these all uh, work we will do by using the application software, means banking app. So this banking app request, it sends the request to the DBMS, okay. And then designer, DB designer means job is to decide what data needs to be stored and how it should be organized. Okay, what data needs to be stored and how it should be organized in the database. Okay, and they create the blueprint schema, which is also called schema, for the tables, relationships, and constraints. Constraints means conditions. Relationships means between relation between two tables or data, etc. And tables, we already know, contains rows and columns. So they create the blueprint for tables, relationships, and constraints. Okay, and then and here is the DB designer, and then DB administrator, DBA. While the designer builds it, the DBA means database administrator manages it daily to ensure it is fast, secure, and always available. The database. Okay. So, uh, tasks include granting or blocking user access, okay, and blocking up data to prevent loss, and monitoring system performance, and administrator software. Here is the DB administrator and DB administrator software, which is used by this DB administrator. Okay, and then DB administrator software means software that provides a visual interface for managing database servers, running administrative scripts, and monitoring system resources. So, and used by DB administrator. And examples is SQL Server Management Studio SSMS for SQL servers, PG admin for PostgreSQL. These are the DBA. These are SQL Server Management Studio and SQL Server Management Studio and PG admin. These are the DBA administrator softwares, and this SQL Server and Postgre are the examples of the DBMS. So this software, this DBA administrator software differ for each example of DBMS. Okay, because the database management system is different, differently designed. So it requires different softwares to manage it. Okay, and then we will see the evolution of DBMS. So has a evolution of DBMS has a transitions from manual physical file system to highly automated cloud based and intelligent systems, focusing on increasing efficiency, data sharing, and accessibility. So here means the how the DBMS is developed from the beginning. Okay, that concept is the evolution of DBMS, and has a transition from manual means manual manually man work, so physically file systems to highly automated means mm, uh, which done the task automatically by its own. Okay, and cloud based means the cloud means it will store large amount of data over an internet connection. Okay, and intelligent systems, forcing on increasing efficiency, data sharing, and accessibility. And then there are four stages. First is 1960 stage, and second is 1970, and third is 1980, and fourth is 2000. Okay, 2000 to till now. So first stage, in the first stage, the technologies are file system, data collection, database creation. Okay, so here we use, in this technology we are using basic storage devices like punch cards, magnetic tape with little independence and high duplications. Okay, and then file system, it specifies how the data is stored on the drive and what type of information can be attached to the file name, permission, and other attributes. Okay, so Windows supports three types of file system: NTFS, FAT32, and exFAT. So their full forms are here. NTFS means New Technology File System, exFAT means Extended File Allocation Table, FAT32 means File Allocation Table 32. And another one is also there, REFS, Resilient File System. Okay, so this and next we are moving to next stage, 1970s. So this is the example, file system is the example of 1960 stage. Okay, and 1970, 1970s, in this the technologies are hierarchical and network models. Okay, example are IMS and network DBMS. Okay, used rigid structures, tree and graph to manage data. Okay, tree means you already know, you have already known that it is like this tree, nodes will be there. Okay, it will expand like this, and graph, it has vertices and edges like this. Okay, these are called nodes or vertices, these are called edges. Okay, these are called nodes. Okay, so here, we are here. Use rigid structures, tree or graph to manage data. Means to store, retrieve, and facilitate access. Okay. So examples are IMS, Information Management System, is a hierarchical database. Means tree like structure. Okay. Where the data is stored using COBOL language. Okay. Is in different levels. So data is stored in different levels and each entity depends on higher level entity. So here is the structure of IMS. So each box is a level. Okay, each entity depends on the higher entity. Disk storage entities depends on the operating system depends on the access model, and so on up to end user. Okay, so here is the explanation of this diagram. So, application, the high level software or program that a user interacts with to perform specific task. As we have seen earlier also this definition. And example, banking app. Okay, and then data language interface, DLI, the command language that acts as a bridge. It allows application to communicate its data need to the need to database. So it allows application to communicate its data. The application's data needs to the database. Okay. An example is a specific command like get unique, used to find a specific record, means a row. Okay, record means a row. Then IMS, database management system. IMS, data manager. Okay, IMS, data manager. So the brain that manages the physical data, it handles storage, retrieval and organization of records in a hierarchical structure. So it's an hierarchical structure, means tree structure. It handles store, retrieval and organization of records, means rows in a hierarchical structure. Okay, the example, the engine that knows exactly where the saving account data is located on the disk. So as it handles the storage, retrieval and organization, it should be known that where is the saving account data should be is there. Okay, then here is the IMS database manager, this whole thing. Okay, DL, DLI we have seen here, DLI, and this is the IMS database manager. Then what is access model here? Access model is a access method, sorry. Access method, the specific technical technique or pathway used to read from or write to the physical storage. Okay, example, using an index like a book's index to jump straight to the right page instead of reading every page. Okay, then what is operating system? Software that manages the computer's hardware and provides essential services to the data manager, database manager. It is database manager. So provides the essential services to the database manager. It is the database manager. Okay, it provides the resources, hardwares and services, other services, okay, to the database manager. And then access more access method is used to read from or write to the physical storage. Okay, and then disk storage. Disk storage is a physical hardware where the actual raw data is kept permanently. Okay, the example is server hard disk. The server hard disk containing the raw containing the rows and columns of bank transactions. Okay, so it contains the rows and columns of the bank transactions. And then it should be permanent, it should not be temporary. Okay, because because at any time we can need the bank transactions. Okay, then transaction manager, here is the IMS transaction manager. So here the it is a traffic controller, means it manages the communication between terminal user and the application. Here is the user and the application, it manages the communication between them, so ensuring multiple requests from users are handled in order. So like request like login request. Okay, so considering 100 different tellers all trying to log in at the same time, so it manages it, transaction manager manage it. Okay, then these how these levels are related to each other and what they will do means, so the application sends a request through the DLI. Application means software. So through which user provides a request. Okay. So application sends the request through the DLI. DLI, what it does, it allows application to communicate its data need to the database. Okay. So then IM transaction manager handles the communication side, the user login and the message being sent. Okay, and timing also. And the DLI passes means DLI means what? Data language interface. Data language interface passes the data request down to the IMS database manager. Here is the whole thing is IMS database manager. This data language interface passes this data request, which is provided by application, to the IMS database manager. Okay, to this box. Okay, and DLI passes the data request down to the IMS database manager. The database manager understand logic of command which we have sent. Okay, the get unique command to find the specific row. Okay, get unique command which we have sent it through the application. Okay, so database manager understand logic of get and uses a specific access method to talk to the operating system. So it uses a database management system uses a specific access method. Access method access method what means? A technique means or pathway used to read from or write to the physical storage. Okay, so it understands the logic of the command and uses specific access method and to talk to the operating system which provides the services, which finally pulls the raw bits from the disk storage. Okay, from the disk storage. The data travel back up the chain to the application, which then displays it to the user. So through this process, the user gets the data. Okay, and then so in the conclusion, we can say that application asks means the request it sends. The DLI translates. Okay, translates to the IMS database manager, and the manager coordinate means links the access method and the operating system and pulls the raw bit. Okay, which finally pulls the raw bit. Okay, and the access methods fetch the data from the disk. Okay, as we know, access method is a specific technical technique or pathway to use used to read from or write to the physical storage. So here the access method fetch the data from the disk, and then it talks to the operating system which finally pulls the raw bits. Okay, so the data is travel back the chain to the application which then displays it to the user. And then here and then you will see next example of a 1970s stage that is network model, network DBMS, or network model or network DBMS. So here it is based on network data model and allows each record to have multiple parent and child records, child records. So here the student record has a two parents, and CSE branch and library has a one parent, and college has a two childs with multiple childs. Okay, students have multiple parents. Okay, this is a network model. So here what is data model and what is network data model means. A data model means high level business view or the conceptual framework, means it is a imaginary. Okay, conceptual framework means imaginary blueprint that defines how data is organized, stored and managed. Okay, it dictating the relationship between data points and the rules to ensure data accuracy. And network data model is a database structure where entities are represented as nodes and relationships as edges, as we have seen here. These college, CSC branch and library students are entities. These are represented by nodes. These are the nodes, and the relationships are indicated by edges. Okay, then so what is entity? Entity is a thing in real world that we want to give information about. So like about a student, about a college, or about a branch. Okay, like that. And leave this point. This is not there. So so the network data, it is network DBMS is based on the network database and allows each record to have multiple parents and child records. Okay, and then we will see the 1980s stage. So in this the technology developed is relational database management system. Use SQL to organize data into tables, rows, and columns for easier data manipulation. Okay, SQL is a language. Okay, through which we communicate with the database. Okay, to organize data into tables, rows, and columns for easier data manipulation. Table means rows and columns. Okay. Data manipulation means data exchanging for exchange purpose. And then the example is RDBMS. RDBMS is a program to store and manage data using related tables. Okay, there is a relation between tables. So it stores the data and manage the data using related tables. Here the example is here student. Okay, student, roll number, name. Here are the some roll numbers, here are the some names. Here is the this roll number and name are attributes means properties of the entity. Property of the entity is called attribute. So table name is there here student, and column name is name and roll number, and rows we also call tuple. And column name is a attribute. Okay. And then 1990s stage. In this, the object oriented or object relation database management systems were introduced. Okay, so they are introduced to better handling for complex data types. Okay, so ORDBMS examples are ORDBMS, object relational database management system. So similar to the RDBMS, but in this object class inheritance is directly supported by the database schema, means database structure. Okay, structure. Database structure is what it provides the relationship of data, means storage, manage. Okay, how it is logically related. Okay, it provides the information about the data, how it is related. Okay, so in this or ORDBMS, object class inheritance is directly supported by data schema and in query language, means like so object. So here is the example of it, ORDBMS example. Here we have one class and we have two classes. First class name is car and other is radio. Okay, size is there, color is there, and radio ID is there, and also break brackets break function is there. So size is small, color is red, and radio ID is something, it will be radio id is there, and break method as it is, and class radio, and radio, it's means we can say attributes. Okay, attributes, the class attributes are radio id, price, year, and volume function. Okay, the radio id is some value. Okay, and which is equals to the class car radio id. So and uh, price is 50,000. Price is 5,000 and year is 2019 and volume function. Okay, so these two are related through this radio id. Okay, because it is common in both. The, that's why they are, the classes are related to each other. And then so why it has functions, volume function and break function, uh, I will explain while explaining the object definition. So next is OODBMS, object oriented DBMS, represents data as a object. Okay, data is a raw facts, collection of raw facts, and as a object means what, object means any defined structure in a database that holds, organize, or reference data. Okay, that holds, organize, or reference data. It has three parts. Identity means a unique id that distinguishes it from other objects. Okay, example is, in the real life example, Aadhaar number for each citizen, and it is given by system. Okay, for a student, for a object example, student, it has a unique number, and for different objects like car, it has different number. So it is provided by the system. Okay, unique, ID, which is a identity, okay, to a specific instance. That specific instance can be a car, student, anything, okay. And an attribute, the properties of object is called attribute, okay. Example, if student is entity, then attribute is equals to age, student class, its her or his or her gender, and mark sheet, etc. Okay. And method, object has a three parts. First, identity, attribute, and method. Method is the action, functions the object can perform. Okay. So, what is entity? Here, I have differentiated entity and object. So, entity is a real world entity. Okay, real world thing. Okay, entity is a real world thing which we want to give information. And then entity is a data part contained inside an object. So object has three parts. One is identity, attribute, and method. So it is a data part only. Means this, what is data part, you will understand through this example. So the type of object is indicated by entity, okay. Means the structure, database structure, the type of database structure is indicated by entity, okay. Then example, entity, bank account, it is the abstract concept of a entity. Bank account, it is the abstract concept of a bank account containing a balance. Means abstract means hidden concept, okay. Entity, bank account, it is the abstract concept of a bank account containing a balance, okay. Balance, here balance is a data, okay. Abstract meaning hidden concept of a bank account, okay. The object is an active digital instance of a bank account in an object oriented database. It contains the data balance 500 plus the built-in code or method to run actions like deposit or withdraw. So it contains built-in functions also. So that's why it is different from entity. Object is different from entity. Okay. So this car and radio is also the objects. Okay. Because it contains the built-in functions, brake and volume. Okay. So then entity contains only the balance and object contains balance plus deposit and withdraw functions. So that is the difference. Entity are conceptual, means only what we draw on a whiteboard, okay. Object are technical, what we actually create in computer memory or database, okay. Then then we have, so hope you understand the what is object. Then object oriented database management system represent data as objects, so allowing for complex data structure and relationships. So object is a structure, So that's why it is allowing complex data structure and relationships. It combines database functionality with the class inheritance and polymorphism. It also includes the class inheritance and polymorphism. This class inheritance and polymorphism is are the object oriented programming language features. So it includes that also, this OODBMS. Okay. To handle the data, to store or manage the data. Okay. So then here person, student, doctor, engineer are the objects because they contain functions. Here set name function, set mark function, count operation function, count page function. So name, age is the are the attributes of this object, and SID and branch are the attributes of the student object, and DID and specialist are the attributes of the doctor object, and EID and department are the attributes of the engineer. Then we will see the next stage, that is 2000 to present till now. So the technologies are NoSQL, cloud, and modern DBMS. So leverages cloud systems. Example, Amazon DynamoDB to handle massive unstructured undistributed data. So what is cloud system? Cloud system. Cloud system is a database management system hosted on remote. Okay, is a database management system only. Hosted on remote means over the internet, cloud infrastructure rather than on premises local servers. On premises local servers means within a building, the company organizing the computer and its hardware and using the data. Okay, so that means on premises local servers. Okay, and it allows the cloud system allows organization to store, manage, and query data over the internet. So it allows organization, not the users, one or two or multiple users, not the users. It allows organization. So we can imagine that how it should be large. So over the internet and handling heavy workloads with high stability, high scalability, and automated backups and flexible pay as we go pricing. Okay, and then so it's an we have seen that cloud system is a database management system hosted on remote means over internet cloud infrastructure rather than on premises level, local. Okay, then so in this 2000 to present till stage, it leverages the cloud systems. Example is Amazon DynamoDB to handle massive unstructured undistributed data. Unstructured undistributed data means information that lacks a predefined format or model. Okay, instead of neat rows and column, it consists of free flowing content like text, images, or audio and video. Okay, and undistributed data means data stored on a single central system or a single physical server. Okay, it is not broken or copied across multiple network connected sites. Okay, that is called undistributed data. And so So in this we use the messy unstructured and undistributed data. So example is NoSQL, not only SQL, or non-SQL databases. Means we we are not using SQL language in the NoSQL systems. Okay, NoSQL databases comes in variety of types: document, key value, wide column, graph, etc. based on the data model. Okay, data model means conceptual framework, means blueprint. Okay, according to that it comes in variety of types. So that's it for today's class. uh, Hope you understand the video and the concept. And if you have any doubt, ask me in the comment section. And if you feel this video is helpful, then like, subscribe, share, and comment also. Thank you. Bye. I will see you in the next class. Bye. Thank you.